As you look at this slide, it just very nicely introduces this next topic, which is called piecewise functions. It happens to be a topic that many students struggle with, and I think not just because it has multi-steps, but because we're not comfortable enough with our graphs. So hopefully that's not the case for you as you go through this particular chapter. You'll notice that it just kind of affirms the things that you already know. I'll hopefully give you today a neat approach as to how to handle piecewise functions. And even though it takes a little bit extra work, I think it's worth the time so that you can get the graph correctly. As you look at this slide, it says there are two equations graphed to the right, well, in this case it's to the left. Name the equation to A. So let's just look at equation A in that graph. And what equation would you say that that would be? My hope is you recognize that as a parabola, and y equals x squared. And the equation to B, of course, is a line. More specifically, it's a horizontal line, which means that that would be y equals a particular number. And let's just say, for all intents and purposes, -1. So this has two separate graphs here. And what we're about to do is learn how to create these. And you'll notice that the point of where one graph stops, the other one starts, is at 2. And so the way that we would write this instead would be that f of x, or the function, is equal to x squared, and it's equal to when y equals -1. Well, when is it equal to the x squared graph? When does it follow that pattern? It follows that pattern for all the values that are less than 2. And then at 2, it picks up, and greater than 2, it picks up with that -1. And I'm going to throw on here an equal to. How do I know if something is equal to or not equal to? Why is it the x squared graph is not equal to, but the line is equal to? And of course, that's indicated by the dot. This is filled in, and this one is an open circle. I hope that helps a little bit as we spring forward into the other graphs that we're about to look at. Now let's look at an actual set of equations where we're not given the graph, but we're given the sets of equations. Again, you're going to notice that there is one point of contention, and in this case, it's -1. Eventually, we'll branch out to where there may be more than one number at this spot, and what I like to call the hot spot. But for now, let's just kind of work our way through this. Again, notice the fact that at -1 is the problem spot. And so for each of these in our graph, as we look at this, at -1 is where there's going to be a whole lot going on here. And so my suggestion, since many people are not very familiar with how to do graphs, we're going to look at 3 separate tables. And so for every single table, we're going to set up, every one of these is going to have to do with -1, because that is the point that we're kind of all focusing on. And so this one says x is less than -1. So I'm going to start at -1, but then I'm going to pick numbers that are less than -1, such as -2, -3, and however many you need till you can establish the pattern that's going on there. In the next section, or the next equation, this one says x equals -1, and so we only care about at x equals -1. And this last one says x's that are greater than. So I would have -1 and then 0, 1, 2, and I would pick x's that are greater than -1. So back to our first chart. Our first chart says for the x's that are less than -1, we're going to use this equation. And so I would plug -1 into that, giving me -3, -5, -7, and -9. And so as I draw this graph, one of the other things I need to pay attention to is it's not equal to, and so therefore it would be an open circle at -1, -3. And then -2, it would go to -5, and so on down. And so that part of the graph would continue to go in that way. The next graph says that at x equals -1, it is 2. And that's the only information it gives me. So at -1, we're going to go to 2. And we're done with that section of the graph. Check. That section's done. And that's all the information that second equation tells me. x is greater than -1. Again, we're still going to look at what's going on at -1. You might think, well, it's not equal to. Right, but we want to know where that graph picks up from. And so at -1, we'd plug that in, we would get 1. So at -1, we would go to 1 with an open circle. Then we'd plug 0 in. 0 squared, of course, is 0, and 1 squared is 1, and 2 squared is 4. And so it would follow suit with the x squared parabola. And that would give me my piecewise function. And you can see how it skips. I'm going to follow for all the x's that are less than -1 up to this spot. Oops, skip up to the actual equal to, then skip down to here to continue on in my way for the next set of values. All right, well, now let's try one again. You'll notice I don't have one here. If I was teaching this in class, I would probably ask each, a couple of you students to offer up different equations. So let me just come up with a couple. Let's say I have 3x for x that is less than, let's say +2. And then I'm going to say 4 for x is equal to 2. And then I'll say 2x minus 1 for x is greater than 2. Okay, so where is my point of contention here? Where's the point that I want to focus on? And of course, that would be for 2. So for every one of these, we're going to have 2. And this is 2 x's that are less than 2. So I'm going to pick out a few of those. And this one just is at 2. And then this is the x's that are greater than 2. Again, notice all of these start with 2, even though they're not all equal to. And then coming back to that first chart, I would say, okay, x's that are less than 2, I'm going to put in place of x at 2, and I would get 6 and 3 and 0 and -3. And so drawing that part of the graph at 2, I would go to 2, 6 and have an open circle. And then I would have 1, 3, 0, 0, -1, -3. And I noticed that line that would draw right down. Great. At x equals 2, it tells me that it's 4. So at 2, it is at 4. And then on to my last graph here. It says for the x's that are greater than 2, we still plug 2 in there, and I'd get 3, and then I'd get 5, and 7, and 9. And so I would, at 2, 3, have a point, and then 3, 5, and 4, 7, and I noticed that I'd have that lovely little line going on that direction. And so that's what it's doing. That would be the other. And those are piecewise graphs. It's basically taking, okay, I want you to follow this graph for so long, stop, pick up with this graph, stop, pick up with the next graph, and that's why it's a piecewise function. You will notice that it will not fail the vertical line test. That's what makes it a function. You'll notice that you won't ever see 2 full dots. You won't see this filled in and another one filled in underneath it. And so those are some important pieces about these functions that as you look at them, they are in fact a function.